Well, I mentioned earlier there are some environmental issues which have impacted the funding to some degree, and one of the environmental issues is, in fact, the broad geographic distribution of the industry today, and the fact that it's not just centered in the U.S. U.S. still has the biggest market segment share, but the growth of the industry in Asia, the fact that every country around the world wants to have one of these facilities, what we're seeing is a competition, and associated with that competition has been the growth of wafer foundries and to some degree the concentration of process development into a smaller and smaller number of companies each year. And that concentration of manufacturing capability and process development capability has meant that fewer and fewer companies are interested in silicon process. They're more interested in design and products. So where we were a fully integrated industry when this program started, we are now kind of distilled into a few vertically integrated companies and then a bunch of design-only companies that use wafer foundries. And this has led to basically a difference in interest of semiconductor companies depending on their business model of what they want to support on the basis of research. Fewer and fewer companies are interested in supporting the basic silicon capability, the basic process technology. What's the next transistor look like? They'd be more interested in perhaps looking at, well, given the process technology, how do I design, how do I test, how do I verify, how do I mix signals, how do I do various implementations of the technology. So there are fewer and fewer people interested in the base technology, more and more people are interested in kind of moving downstream a bit from the base technology to how do I apply the technology to my product. You know, I guess we could also throw in that although there's discussion annually about how long can Moore's law last, and those of us who've been in the industry a while are fully cognizant and can well remember that we were never going to go below 1 micron because it was impossible, and especially with optical lithography techniques, and somehow we got below 1 micron, and then we were never going to get below, a few tenths of a micron with optical lithography. Somehow we got below that, and now we're getting down into the sub 50 nanometer regime, and we're still all talking about, well, how long can Moore's law go, and how long can optical or lithography go, and when are we going to get into the X-ray lithography? And we've even gotten sophisticated enough that we don't call things X-ray lithography anymore. Now it's extended UV, because X-rays had a bad name for various reasons, because direct projection X-ray lithography never really worked out well. Some companies spent a lot of money there. But we're getting to the point where fundamentally we seem to be looking at the need for a new electronic switch or a very, very radically different type of transistor structure going forward. So this carries with it the fundamental nature of very necessary and well thought out research to what to do next, at the same time when fewer and fewer people are interested in what to do next. So there's an environmental impact here which is impacting not just the industry in the U.S. but around the world.